Welcome to this product application tutorial. My name is Tobias Bruch from GE Sensing and Inspection Technologies. Today I'm going to walk you through the setup and operation of the Palm Scanner series, a solution we've been developing for inspecting the walls on small diameter pipes. These scanners will be offered in 3 different sizes, and today we will walk through the setup and operation of the smallest size, the Palm 50. The scanners are delivered in a hard shell case. They are delivered with an operating manual for the instruction of setting up the scanners. You have a set of tools needed for the setup of the scanner. Then you have the scanner itself. A phased array probe is delivered with the scanner setup. And the wedge you need to couple the phased array probe to the actual pipe. We will now walk through the mounting of the probe to the wedge. For this you need the probe and the actual wedge. To mount the probe on the wedge, you need a screwdriver from the set of tools which is delivered with the scanner. Before mounting the probe to the wedge, apply some couplant to the wedge. Take the probe and fit it to the wedge. Then start screwing the screws into the wedge. Do this on both sides of the wedge. Now you have fixed the phased array probe to the wedge. For mounting the probe into the scanner, first start unscrewing the 6 screws. Unscrew the screws completely until you can take out the springs from the scanner. Now take the 2 springs and fit them to the holes in the wedge. Insert the probe from the bottom into the scanner and place the springs on the position you've been just dismounting them. Then start fixing the springs again into the scanner. Now the wedge is correctly fixed in your scanner. In the next step, we will fix the probe cable to the scanner. For doing so, untighten the screw at the back of the scanner. And place the probe cable under the cable guidance. Then tighten the cable guidance again. You also want to set the probe cable that it runs along this cable guidance. So untighten these screws as well. And place the probe cable. Then tighten the screws again. In the final step, take the tool provided with the scanner to enter the probe cable into the cable sleeve. Do this by putting the probe cable into the tool, rotate the tool, and then start pulling the tool
and insert the cable into the cable sleeve.
In the next step, we will mount the couplant supply. The couplant supply is equipped with a Y connection added at the end of the couplant pipe. This Y connection will be connected to the wedge of the probe. Plug the pipe to the irrigation channel mounted on the wedge. Do this on both sides of the wedge. In the final step, we will now set up the scanner and the probe on the actual phased array instrument. So we move over to the phased array instrument, which is already fired up here, and we will start on entering into the phased array mode. We will now set up the probe on the actual instrument. For starting our setup, we start with defining our actual part we are going to inspect. Operating at a shear velocity of 3,250 meters per second. The actual pipe we are going to inspect will have a wall thickness of 5 millimeters, so we enter this in our thickness field here. In the second step, we are going to define our actual probe. So we move to the probe menu, and we see on the connector of the probe that we have here a 10 MHz probe. So we enter probe frequency down here of 10 MHz. We do see that we have 16 elements, so we enter in the field of number of elements 16. We do see that we have a pitch of 0.4 millimeters, so we enter this into our pitch menu. Finally, these probes have an elevation of 10 millimeters, so we also enter these 10 millimeters in the elevation menu. Once this is done, we are going to define the actual wedge we have been using in this inspection. So we click on wedge. The wedge parameters are written on the side of the wedge. Now it's already mounted in the scanner, so you do that probably beforehand. These wedges have an angle of 45 degrees, so we enter this in the wedge angle menu. The wedge velocity is 2,330 meters per second, so we enter this at wedge velocity. The wedge front is 16.5 millimeters, so we enter 16.5 millimeters here in the wedge front menu. The set offset of the probe with respect to the coupling surface is about 6.8 millimeters. So in the set offset, we enter 6.8 millimeters. In the scanner, the first element is at the lower end of the wedge. So at first element position, we enter low. Once we have done that, we are going to go to our ultrasonics setup. We are going to define an actual inspection range. So we know that our pipe has a range of about 5 millimeters. So we're going to enter here about a range of 9 millimeters in the range end. On the pulsar settings, we can set our actual pulsar voltage, and we need to set the pulsar width here. For the 10 MHz probe we've been using here, we set the pulsar width to 30 nanoseconds. In the receiver submenu, we define the frequency we want to receive. Since we're using 10 MHz, we define the filter here such that the 10 MHz can easily be detected by the instrument. So here we choose from 4.7 to 11.5 MHz. For setting up the scan on the instrument, we enter in the main menu and go to Delay Law. First we enter the submenu Aperture. The probe has 16 elements, and since we want to do a sectorial scan, we are also using 16 elements in our aperture. In the next step,
we are going to define our actual scan. We want to do a sectorial scan, so in the type of scan, we enter into the menu and select sector scan. We will do the sector scan starting from 35 degrees, so we enter angle start and enter 35 degrees. The scan will stop at 75 degrees, so at angle stop, we press the button and enter 75. After we have entered these angles, you will see that now here turns up a Calculate Delay Law button. Make sure that you press the Calculate Delay Law button and you will see how the instrument operates for calculating the scan-out setup. Once this is done, you're done with setting up the scan. Before we do that, we now take once the probe and connect it on the back of the instrument. In a second step, we take the encoder connector from the scanner and hook this up to the instrument as well. Now probe and encoder are connected to the instrument. When we have done this, we need to calibrate the encoder. So we go to menu Scan, Encoder Calibration, and it's very easy to do this calibration directly on the workpiece you've been using. So you can calculate what will be your circumference of your workpiece and enter this in the actual calibration distance. So you go to this calibration distance menu and here enter, for example, 150 mm as calibration distance, which is the actual circumference of this pipe. After doing so, you mount the scanner to the pipe, position the scanner as close as possible to the weld for good coverage of the weld groove. Now you can push the Start Calibrate button and rotate the full scanner over the full circumference of the pipe. You see how the instrument records the encoder increments. And after having done a full revolution, press Stop Calibrate and your encoder is now set up and calibrated. For the actual inspection, we are going to choose a C-scan and the E-scan. You can set this under the menu Display. So we're going to select here A and E and S and B scan in this Views mode. For doing the inspection, we need the actual couplant of the probe to the workpiece. So we take this couplant supply, apply pressure. For doing the scan, we again go to the menu Scan and submenu Run. We press the Scan Start button on the instrument, enable the couplant flow, start rotating the scanner around the pipe. And while rotating, you will see how the image builds up on the actual instrument. Once you have done a full revolution of the scanner around the pipe, your scan is finished and you can press Scan Stop on the instrument. With this, you're finished with inspecting this weld. I hope you liked this video and this will help you in operating and setting up this palm scanner. Thank you for your time and see you next time. You can easily change the encoder of the scanners by untightening the screw at the encoder and then simply pull the encoder out of its housing. It's also very simple to insert a new encoder.
After inserting the encoder, start tightening the screw again.